Hi, my name is Edward Ong, Senior Product Marketing Manager of Power Integrations. I'll be sharing the new and simpler power architecture for appliances using the InnoMux chipset. To start with, let's briefly talk about the existing power architecture used by appliances today. So most of them use what we refer to as a two-stage power conversion. So the first stage consists of the flyback. So let's call that stage 1. And it has an efficiency of about, say for example, 86%. It is followed by a second stage referred to as the DC to DC converters. So each of the DC-DC converters converts the appropriate voltage that is required for the loads that are being driven by each of the outputs. So it could be the MCU for the 5 volt, 12 volt for the motor, and of course the LED lighting, which requires constant current. Now, on the average, the secondary stage efficiency would be somewhere like 90%. Now, the overall efficiency between the two, the total is going to be 77% if you multiply. Now, the interesting thing is that nowadays, particularly for appliances, is that energy regulating bodies like Energy Star and the European Union is starting to require the input power consumption to be significantly reduced. And this is something that we would expect to continuously happen as the years move forward. And because of that, the existing architecture having two-stage would eventually face quite a challenge in meeting future requirements of Energy Star and similar energy regulating bodies. We want to share now and discuss the new power architecture using the InnoMux chipset. And in this case, what we have here is just a one stage. So we've simplified the power architecture from a two-stage approach into a single-stage approach. Now, without compromising any of the regulation for each of the output, meaning even though we're using just one stage, all of the outputs are tightly regulated. So for example, the current flowing through the LED lighting are tightly regulated. And not only that, it also provides capability to adjust the brightness as well as needed. The 12 volt, the 5 volt, they are tightly regulated, better than plus minus 3%. Now, looking at the flyback circuit here of the InnoMux, we could see that we are using multiple output windings. And each of the output would have their own corresponding winding, and we're also using a synchronous rectification for higher efficiency. Now, each of the outputs are independently being monitored. So we could refer to them as having independent feedback loop. So each of the feedback loop goes into this FB block. Now, this FB block also is not just a simple node, but it is actually a smart controller. So this smart controller actually directs the appropriate energy for each of the output. So say for example, if the 12 volt load increase, it will direct more energy there. And so as the dynamics on the load changes, so will the energy will be properly supplied to the output that would require it in such a way to be able to maintain tight regulation. Now there's also a magnetic coupled communication between the secondary and the primary controller through the flux link. So the switching in terms of, duty cycle changes needed and so on are all synced up between the two controllers here. So we're able to simplify the architecture and be able to tightly regulate each of the outputs so there is no cross-regulation. At the same time, we are able to eliminate and simplify the architecture by taking out all the DC-DC conversion stage and having only just one stage. So one stage having an efficiency together with a synchronous rectification, a conservative of 87%. And so if we are talking of a 40 watt output power, the input power will be for the existing architecture is 52 watts. And the input power using the InnoMux with just a one-stage architecture is going to be 46 watts. So we could see that the difference for a 40 watt application is 6 watt. And this is significant reduction that would allow us to meet further and further stricter requirements coming from energy regulating bodies. Now, the good news is that as you go up to higher power, the more power reduction you could achieve. So if you go, let's say, a 60 watt output power, changing to that InnoMux power architecture actually saves you 9 watts. So that's quite significant. For more details on InnoMux, please visit the Power Integrations website, power.com.